Good morning and good evening, everyone. My name is Farnaz Jadbabi, and I'm the Product Marketing Manager at MSC Nastran, at MSC Software, working with MSC Nastran, Patran, and Mark. Thank you for joining this webinar. Today, I'm going to be talking to you about MSC Nastran and the contact analysis capabilities of MSC Nastran. So what I will be talking about today is an overview of contact analysis in MSC Nastran, what is contact and how you can define and create the contact bodies. Then we'll have a short discussion on MSC Nastran. Then we'll have a discussion on the methodologies used in MSC Nastran for segment to segment and node to segment. And then lastly, I will give you a short demo, and also at the end, I'll show you some of the new features and enhancements that we have added in MSC Nastran. So what is contact? The simulation of many problems requires the ability to model the contact phenomena. We will see this in everyday life. This includes modeling interference fit, modeling assemblies, and so many other options that we use in various industries. Engineers from leading companies in many industries use MSC Nastran to analyze and model large-scale assemblies. Here you can see some of the examples for contact analysis. You can see in the auto industry, we use contact analysis to design the brake systems for pads and pistons, or we can use it for engine block design and tires, or many other options. Also, in the aerospace industry, we use contact analysis to design the landing gear systems, for aircraft seat analysis, bushings, and other options as well. But design of contact analysis is not just used in the main aerospace and auto industry. It can also be used for other industries such as electronics, oil and gas, machinery, shipbuilding, and other options. Here you can see some of those examples. We have other applications that are covered with MSC Nastran contact analysis as well. For instance, in the electronic industry, contact is used to design the printed circuit board assembly. Imagine if you had to make the nodes congruent manually on the circuit board and then connect them to the rest of the part. This would be tedious, and it requires a lot of modeling time. So that's why with capabilities such as glued contact, you can quickly assemble the 2D board and also the 3D chip to calculate the stresses. Also, you can use the thermal contact to analyze the resistance and other options. You can also see that we use contact analysis in the shipbuilding industry and heavy machinery as well. So what is contact in general? Design of multi-level assemblies or complex parts that have several components can be tedious at times because these parts are coming from different people, different departments or suppliers. So that's why it's important for an analyst to bring in all these parts together and define how these parts interact with each other. That is what we call the contact analysis. Basically, each part is a distinct physical contact body. So each contact body is one of the parts, and then the contact pairs define the interaction between these parts within the assembly. And as you can see here, we have several methods of contact. It's the touching and glued contact. We will discuss this in detail in further slides. But having contact allows us to capture the real physics of the structure. In structural problems, it is important to follow the proper load path. The numerical objective is to detect the motion of these bodies and apply the constraints and to avoid penetrations. And then later, the solver will apply the correct contact constraints, and then we can simulate the interaction of the parts. Before contact was introduced, there were other options that people were using in MSC Nastran or even other softwares. For example, in Nastran, one can use the C-gap, but the C-gap had some, or the linear gap. But the linear gap actually had some challenges because it was hard to align the nodes and split the meshes and assess the structural performance of multi-level assemblies using this method. So this is why we are recommending to use contact. Also, traditionally, the bolted or riveted aerospace assemblies were modeled with a continuous mesh where the nodes were aligning. However, this is not the case today in so many cases because the continuous meshes are often replaced by individually meshed parts joined by some type of connector. So to manually connect these parts, it's going to be very hard. That's why we recommend using contact. You can see here on the right-hand side where we don't have the meshes congruent. This is a case that contact analysis is going to be very useful. Compared to all other older methods, such as linear gaps or modeling techniques, other meshing techniques, contact in MSC Nastran is far more productive and efficient. It is effortless. The effort is much reduced because you don't need to create any common nodes or congruent meshes between the parts. You don't need to know the general area of contact or have cumbersome selection of the contact bodies. You don't need to create additional contact elements. You don't need to define any type of elements for it to be contact. And you don't need to mesh your rigid surfaces. You can just use your CAD geometry and define rigid bodies. Some of the benefits of contact analysis over the other methods. Contact is much more accurate and also it's versatile. Why do we say it's versatile? Because you have several options. You can define different types of contact that are available, solid to solid, solid to shell, solid to beam. You can also define thermal contact, or you can define a coupled thermomechanical in MSC Nastran. And why do we say it's accurate? Because contact allows you, especially for complex assemblies, to have a better load transfer and also capture the correct load path and the physics of the structure. If you don't define contact between the parts, they're not going to see each other, and the parts are going to pass through each other. You can see that on the right-hand side. Whereas when we have contact, the parts, you're going to define how these parts are going to interact, whether it's going to be glued or whether it's going to be touched or etc. Some of the options available in MSC Nastran. These are the different contact types. I'm going to start by talking about the permanent glue contact. Permanent glue contact is the first one that we're going to discuss. In this case, the bodies are fixed. It's kind of like a fixed or velvet kind of joint at the contacting surface. So that's why there is no relative normal or tangential displacement between the parts. This is the best option, an ideal option when you have to model multiple parts in a structure and quickly assemble the components together that have the similar meshes and connect them to create a full assembly. So there is no need to have the same size elements. There is no need to have congruent mesh, and both bodies need to have, you can contact several bodies together. And this is supported in Solution 101, 103, 105, all the dynamic solutions, the optimization solution, Solution 200, and also our nonlinear Solution 400. One thing to mention, though, this is only appropriate for small displacement analysis. So that's, even if you're using it in a Solution 400, you have to have small displacement analysis. When using the permanent glue, the initial configuration is used to determine the contact constraints. So there's no iteration, and the contact change does not happen. Once the status of the contact is determined, it's going to keep that throughout the analysis. And one important option is to note that with the permanent glue contact, the parts have to be in contact originally. So if they're not in contact originally, you have to define the distance tolerance in a way that the contact is found properly. If the nodes are not initially in contact, then they will not come into contact unless you increase the distance tolerance. The second option that we're going to talk about is the general glue. So this is a little bit different than the permanent glue, okay? So unlike the permanent glue, in the general glue, the bodies don't have to be initially in contact. What happens is that they can come into contact during the analysis, and depending on the separation criteria, whether it's force or stress, the parts may separate. So that's one benefit over the permanent glue. Another thing is that this is only supported in solution 101 for linear static, in solution 400 for nonlinear, and our solution 600 and 700. And this is an incremental and iterative process. Even in a solution 101, the only source of nonlinearity would be the increments that happen within this contact. So one benefit, as I mentioned, is that the parts don't have to be in contact, and also the parts may separate. And here you can see that the contact nodal forces and stresses are output in the FO6 files for the user. How to activate it, I'll show you how you can do it in Patran, but in MSC Nastran, if you want, you can just define a BC para entry and define NL glue 1. So that means like nonlinear type of glue. The next option that I'm going to discuss is the step glue. This is a little bit of a newer option that was added a couple of years ago. So MSC Nastran has been supplemented by a concept of step glue in which the regions that are initially in contact will remain permanently in contact. So this is important to notice. If they're in contact initially, they'll remain in contact and there is no separation. However, if they're not in contact initially, in the very initial step before any load is applied, they may come into contact and stay glued, or they may separate. And imagine this is like a type of a glue, but for large displacement and large rotation analysis. And this is only used in solution 400. So again, the regions, if they're initially in contact, they'll remain in contact permanently and will not change throughout the load step. However, if they're not, they can come into contact. Another important thing to note in using step glue is that the contact search is only performed in the beginning of the step. The contact status is checked at the beginning of each step, and it will not update throughout the step. And then the next step starts, and then it's going to do another search. Now, we talked about all different types of glue contact. The other type of contact we have is the touching contact, which in this case is kind of similar to general glue, but there is one main difference, and that is that the parts, again, similar to general glue, the parts may come into contact and can separate, but there is sliding. So in general glue, we did not have any sliding, but in the touching contact, we have sliding. The parts may slide along each other's surface with or without friction. And in touching contact, you can define friction. We have two different types of friction in MSC Nastran, the column and shear. And also, again, since this is used in solution 101 and solution 400, it's type of an incremental and iterative process. So this is also important to note. The contact force will be checked against the separation force, just similar to general glue contact. And if the separation force criteria is exceeded, then the parts may separate. And if the if the pulling force is less than the separation force, then the bodies will remain in contact. And you can see here we have some examples shown, and it's very useful for defining bolts as well. Here you can see some of the applications of the contact. I just wanted to mention one item. Even if we use contact in solution 101, it's important to note the terms linear and contact are almost immediately in conflict. So in general, it is a nonlinear process. However, in solution 101, the permanent glue, you can use the type of contact that's only applicable to slide to a small displacement and small rotation. So that's why you use it in contact in solution 101. However, I just wanted to mention that the process is a linear process. How do we know we need to run a nonlinear analysis? In general, the rule of thumb is that if your strains are approaching 5% or more of the deflection at any node in your model, approaching 5% or more of the smallest dimension, then you should do a nonlinear analysis. So that's why we recommend using the contact with the solution 400. That's when you need to switch to solution 400. Some of the items that nonlinear contact will provide to you, for example, you can here see we have large strain and large rotation. You can see a lot of movement in this track on the right-hand side, lower right-hand side, a lot of movement, displacement going, and you see the large deformation. The track is going through a set of rollers here. You can use it for interference fit in the cases where the displacements are large. You can use it for preloaded joints, as you can see on top, for bolt analysis. So these are some of the options that are available for large rotation, large displacement contact. Another application of contact is the thermal contact that we have in MSC Nastran. This allows you to define the heat transfer between the bodies. It's very useful in the electronics industry, and the thermal contact allows us to accurately capture the thermal gradient between different components. It can be glued or it can be touching. And we can see here the thermal contact with glue on the right-hand side and the thermal contact with touching on the left. The temperatures are continuous when we use the glued case. And we can see, sorry. I think we lost the screen. Okay, yeah, it's coming back. So also, we can define temperature-dependent material properties when using the thermal contact. And again, as I mentioned, one can define thermomechanical analysis as well. So how to create contact in Nastran? You can define different types of contact bodies. Contact bodies are in two types. First, we're going to talk about the deformable contact bodies. These can have stress and temperature distribution, and one doesn't need to select the elements one by one. It just has a minimal effect to select the elements from a contact body. You can use, I'll show you how to do this in Patran. There are several methods. You can define it manually, or you can use our Patran automatic contact tool that creates the contact bodies. Deformable bodies work with both large and small deformation, and one can apply the normal boundary conditions to the deformable bodies. And we don't need to match the mesh between the parts, but it's just important to have a distinct physical part. The next option that I'm showing is the rigid contact bodies. These can be modeled with the geometry or with the finite elements. So one benefit is that if the part is very, very rigid, then you don't need to model this with a FE model, and you can just define, use your CAD geometry and define the rigid contact bodies. There is no stress distribution through that. and it uses the mathematical representations of the geometry. So for 2D surfaces, we use the curves, and for 3D, we use the surfaces to define the geometric boundary. There is no need to mesh it. You could mesh it if you want. And it's using the analytical representation to improve the accuracy, especially in cases where we have a curved surface. That's going to be much more useful. And there are 3 ways to define the motion of the rigid body. One is to use velocity, one is to use displacement, or one is to use load. And for the cases that you define a load to define the motion of the rigid body, one can use control nodes and define a force or moment for the control nodes. If you need more information regarding these, feel free to contact us or go to the user's guide that we have on our STEAM companion page. You can see the user's guide that has information on contact analysis. So I'm going to show you a short demo on how to create contacts in Patran and how to set up the model. So here I have Patran up. I have not created the model. We have created a session file, which it's easier to bring the model. So you can just go to File, Session, Play, and then bring in session file that you recorded previously. That means that you perform some steps, and then it records it in the Patran command language, PCL, and you see how quickly it can create the model. So here it's a very simple model that I'm just using for test purposes. We have 3 blocks. We have a cylindrical block and the other 2. And you can see the mesh on the green one is much finer than the mesh on the red one. I've already defined the boundary conditions. Here, this one is fixed in 1, 2, 3 in displacement. However, it's free to rotate. And instead of applying a load to this cylindrical one, we're just applying an enforced displacement, which is equivalent. It's important to note when running contact, whether it's a solution 101 or any another solution, you got to make sure that rigid body motions are properly, like there's no rigid body motion in the model, so they're models properly constrained, and then the contact comes into play and helps with that as well. If your model is not stable to run in a linear solution, your contact model will not run properly. So here I want to define the contact bodies. There are 2 options available for me. One is to go under load boundary conditions and just go and define them and pick the bodies each one by one, whether pick the geometry or the elements. But there is an easier method that I like to use. So you can go to Tools, you can go to Modeling, and here we have Contact Bodies and Pairs. This window allows you to create contact bodies automatically inside Patran. And you can create the body pairs. As I said, the pairs define the interaction, whereas the bodies are the actual part. So first we'll define the contact bodies, and we're defining the formable. Here we are given several options. It allows you to define the bodies based on the element type, whether, like, let's say you have 2D elements, or you have shells, or you have solids, hexes, and etc. You can define them based on the group if you have put a certain part in a separate group, or you can define them based on the actual properties. So in this case, I'm going to use properties because each of these bodies have separate properties. And then click Apply, and you can see here that it created 3 bodies for us. We can see it on the model tree. So we have the 3 bodies created. The next step is to create the body pairs. Again, you can go here on the same tool and define body pairs, or you can go on the load and boundary conditions and then go under body pair menu. Now, one thing I want to mention, for Patran, in order to know where to search to look for the bodies, you have to give it a tolerance. Please note, this is different than the distance tolerance that Nastran uses for defining contact between the nodes. So this is just in Patran to create the contact bodies. And based on a trial and error, so I've just given it a 0.25. If it's too small, you may not catch all the bodies. and we're using all the defaults, and then I click apply, and you see here I have 2 contact pairs created, one for the 2 blocks, the green and the red, and one for the cylinder and the other block. And by default, everything is set to touching. So that's why for this example, just to show you, I want to make one of them as glued and the other one as touching. So that's why I'm going to go and modify one of them and create a touching contact pair. That is a touching pair, and the second one I'll make a glued contact pair. So for that, I'll go under load and boundary conditions, and then I'll go to body pair, and then I'll create, the action is set to create, I'll just switch it to modify. We're modifying the contact, and we're modifying the body pair. So it's very easy, action object type. And we just want to modify the 2 blocks and change that to glue. So I'm going to click on modify data, and here, if you want, you can rename it as well. Here, please note, I'm going to check glue contact. So this allows me to select the glue option. And you can, again, as you see, we have several types of glue available. So in this case, we're using the permanent glue. And I also want to retain the gaps and overlaps between the bodies. This is a useful option in case that my parts are a little bit separated and they have a gap and then sometimes they have an overlap. This is going to help. And here you notice that we have double-sided. I'm going to go into detail for these further in the PowerPoint. So I'm just going to click OK, and you click on the application region, and you can click here to pick the bodies, but it's already picked for me because we use the automatic generation tool. And here we have one body as the master and the other as the slave. I'm going to talk about these further. So click apply. Now I'm going to go back to my PowerPoint presentation. So this is how you define contacts in Patran. So going back, again, it's talking about the same thing I showed you. This is the automatic tool to create the body pairs. This example is just 2 plates, as you can see. It creates the pairs between the 2 bodies. Now, I want to talk about the contact methodology in MSC Nastran. There are 2 methods and 2 algorithms available. The first one is the node-to-segment that I'm describing here. So in this case, we have slaves and masters. That's what I showed you in Patran, as you could see. One body is considered as a slave and the other is considered as a master. So the slave node will touch the master surface. And once the search is started and the contact is detected, then it's going to project it and create the constraints. But the user has to identify which bodies are the slaves and the masters. So this is one thing that can be hard sometimes. So we have some tips that I will show you in the end. And it will create multiple constraints if you're using glue or if you're using node-to-segment to make sure that there is no penetration that is occurring between the bodies. And it's available in both linear and nonlinear analysis. So the motion of the node is checked to see whether it has penetrated or no, and when the node is detected to be in contact with that segment or that master surface, the constraints are created. Now, these are some of the options. How does it know when it tries to search? How does it know that the nodes are created or that the nodes are found in the contact or no? So the slave node to the master surface can have several positions, and there are several scenarios that I'm showing here. The first scenario is when the node is outside the element segment. And in this case, it's outside the contact tolerance. That's important. That's another concept that is important to note here. You have to define the distance tolerance in which the solver is going to search. So if the node is outside the element segment and outside the contact tolerance, during the incremental procedure, Each potential contact node is checked to see whether it's near the segment or no, and this is defined by the distance tolerance that the user provides. So the first scenario we'll see here. The second scenario is when the node is outside of the element segment, but it's inside the contact tolerance. This is when the contact is detected. So in this case, the contact is detected properly. The third case is when the node is inside the element segment and is inside the contact tolerance. In this case also we see that the node is going inside of the contact. So the scenario 3 contact will happen as well. But the one that you want to avoid is the scenario 4, where in this case you'll get some penetration. So if the node is inside the element segment, and then you will see here on the fourth one that you'll have some penetration. So this is the one that you want to avoid. Now I want to talk about some tips. Before specifying the contact, some of the options that you can define for your node to segment contact, and I'll show you some of these in Patran as well. Make sure that you define the proper contact tolerance. Again, as you saw in the previous slide, if you don't define the proper tolerance and stick to the default, sometimes it works, but it may not work depending on your model if it's a complex model. So it's important that you do that. And make sure that you define the initial gaps and overlaps. You saw that in Patran also. If your models are separated or they have some overlaps due to some design iterations or anything. If you're using node to segment, you can use a command and punch out the multi-point constraints that are created for contact, and this allows you to punch those out and visualize them in Patran. This is a good check to see if the Nastran created the proper ones or no. Now, if you are using touching contact, make sure that you define the friction properly if the model is asking for it. And if you're using node to segment, there's an important tip, and usually the rule of thumb is to have the body with the finer mesh as the slave. I'm going to show you later on in this model how this can make a change. Also, there is a search method that Nastran will do, whether it's going to search from slave to master first or master to slave. There are several options available, but the best is to keep the automatic option where the solver decides how to do the search. So I'm going to show you that as well in the Patran demo model. So also use you can use a nonlinear parameter and enter that in your Nastran input file, and to get some more debugging outputs available to you in your F06 file to get the distance tolerance, see what the solver used, or any other nonlinear iteration outputs available to debug the model. And if you're still running into issues, you can always call our MSC technical support. So I'm going to go back to Patran. So here in this model, we have defined the glue, but I want to show you some of the items that I talked about. So you see, this is where you can define whether you want to have a single-sided search or a double-sided. So at first, we're going to run this model with the double-sided and then check the contact status, and then later on, we're going to run it with the single-sided or use the automatic method, actually, and the method that uses the proper slave and master if the meshes are different, and then you'll see how the results are a little bit better. This is where you define the glue. You can define the distance tolerance that we talked about here. And here you can also define whether you want to run the node to segment or segment to segment that we discussed. So I'm just going to run this. We have defined the contacts. I've already defined the materials and the rest of the model because I didn't want to take so much time here. So just going to go to the analysis form. You can set these all to analyze, and we want to run the entire model. Here we're going to select a solution. You have several options for contact, but for permanent glue that we're using here in this case and the touching, we're using linear solution. Here in the solution parameters form, this is where we define our contact parameters. So these are some of the other options that we discussed. For example, again, you have an option to define whether you want to run the node to segment or the segment to segment that I will discuss shortly. Or if you want to define your distance tolerance, you can do it also here as well. You see how it says contact detection. This is the bias factor that I haven't talked about, but this is useful in the touching contact. For further detail, you can refer to our users guide. These are some of the options for shell contacts if you want to have the shells to offer the top layer or the bottom layer. And this is where you, remember how I said the nonlinear glue? This is where you deactivate your permanent glue and use general glue. So these are some of the options. Also, in this example, I want to make my separation criteria for the touching contact based on the stresses. So, and I'm going to use the extrapolation method. So, and then I'll click OK. And another thing you want to click here is to pick the output file that you want to use. Usually I use the NoP2, or you can, with the newer versions, you can use the HDF5, which is a very useful format. And then click OK, and click OK, and click OK. In order to save some time, I've already run this model, but I can go ahead and look at my results. And you go back to the analysis form. If you want to use the HDF5, you're going to select it here and attach the file, but today I'm just going to stick to the output, the OP2 file. So I'm going to use the attached output file. And here you select it, and you can see that we run the model, and we have it. So I've already attached it to save some time, and I'm going to go to the results tab. Or actually, no, I didn't attach it, so I'm just going to attach it. Okay, so this is the one that we have, solid model with contact. Oops, didn't select it. Okay, you see here it says end of attached results. So we're going to look at the results. You can look at the contact status as SC0. So this is the initial status that contact has been, the very first step that will tell you if the contact was detected properly or not. For that, I'm going to use a marker plot, which is much easier. I'm going to show you here. This is one thing that you always want to do. So you go to the SC0 and select the contact status, and there are several options that you can define. It's by default, it's set to, the markers are very big, so I'm just going to reduce the size of the markers and switch it back to a sphere, which is easier, and then I can view it. I'll go back, and we have defined the contact status, and you can see here. So these are zeros and one, and if I go to the groups and only post one group, you can see better the contact status. So you see here in this plot, we did not get that many, and it shows that these nodes have been detected in contact, and I think that's because the slave and master was not defined properly. So that's one thing I wanted to show you. Now, if I go into my load boundary conditions and I switch my contact and change the search method from the double-sided to an automatic or to a single-sided and define my master and slave properly, I have run the model again, and you're going to see that I will get a better contact. So that's one thing that I want to mention, that for node to segment, it's very important how you define the search method. So we recommend to use the automatic method, and also it's important how you want to define the master and slave. So generally, this one is the body with the coarser mesh. So the one with the finer should be the slave, and the one with the coarser should be the master. So I'm going to go to the application region and make sure this is proper. So this is the coarse body, and I have it as the master. So master is the body that is touched, right? Remember, so the node goes to the master surface. The slave node goes to the master surface. And I'm going to show you the results of the second run that I did with the slave to master switch, and also using the automatic search method. And I'm going to attach Okay. Here, I'm going to show you the contact status. We have two because I have attached two results files. And on the same body, and you're going to see some improvement. You see, now the contact detection has been much, much better. And in Patran, they're defined by zeros and ones. And the 0 is the master node, and the 1 is the slave node. So you see here, this body was the cursor body, so this is the master. This has the 0. And then if I switch the group, you can see the other one. You see that the contact status is improved. So these are some of the important options that I wanted to mention to you. Now going back to the PowerPoint. So I also wanted to mention some items about the segment-to-segment method to you. This is a newer method, and it's a better method that we recommend to use because one main reason, as you can see, there is no slave to master. So that's the benefit of using segment-to-segment. How it works is rather than creating a node and rather than looking at the node to surface projection, it's going to divide the edge or face of your contact body into several segments. And on each segment, it's going to add some auxiliary points, as you can see here from the picture. And these points are going to be checked for a distance check, where the distance is defined, it's kind of like a distance tolerance, and for a normal check to make sure that the normal is more than some value. So I think the default is 120. Once it passes this check, it's going to project these segments into polylines for the 2D or polygons in the 3D, and then it's going to create some points on those polygons, and it's going to create the projection and detect and create the constraints between those polygon points. So this is a much newer method, and it's a much better method in a way that you don't have to worry about the slave to master. What we just saw, you don't have to worry about it using the segment to segment. And that's why we recommend to use. So it uses the penalty method. Some of you might be familiar with that. If you need more information, you can always refer to the user's guide. Some of the advantages of using segment to segment, as you can see, we have a better contact footprint. There's a better stress continuity because there are more points on the segments. Also for shell contact, shell edge contact, because it's using the segment, it's going to use the full shell space. So as you can see, the contact status, it's much more and it's better using segment to segment. So this is the recommended method to use over node to segment. Now, we're running a little bit out of time, so I'm going to go quicker. We already talked about the methods of contact in Nastran, the algorithms, the segment-to-segment, node-to-segment. We talked about different types of contact in Nastran, whether you have permanent glue, general glue, and now I want to give you some information about the new enhancements that have been available in Nastran for the past couple of years. One is the ability to define variable initial gaps and overlaps. Before, we had an option to define the gap and overlap. However, it was constant. But there are so many cases where the user has models that are either using fly drop-off, or it's because of so many design iteration changes, or because of so many options that you may have several gaps and overlaps which are different and are changing throughout. For example, we can talk about the ply drop-off. Since we don't create the properties for each ply drop-off separately, it's sometimes easier to make a full property for all of them. So that way, the plate thickness may not be the proper thickness, and it's idealized with a step change in the thickness. So that's why you may end up with having gaps and overlaps. So in that case, you cannot, it's going to be tedious to go and change all of those gaps and overlaps one by one. That's why we defined, we allow to define a variable initial gap and overlap in Nastran. And it's very easy. You just use an OPI NGP entry in your Nastran input file. For more information, please refer to the user's guide. The quick reference guide also has some information. Here, for example, you can see sometimes the design changes happen, and like the model is changed and it doesn't convert, so then you have to make a change to the design, and we have like iterations happening. So that's why you see that the thicknesses are messed up and they're different actually. So for example, here, as you can see, the thickness on the L bracket is much higher, and we see some penetration and some overlaps. So that's why it's important to use the variable initial gap overlap parameter before running the analysis. You can see how it improved the contact status on the right-hand side lower image. You see the contact status is much better in comparison to when we did not define this parameter. So this is a new capability that has been added in Nastran for the past couple of years, and it's very useful. Here you can see the ply drop-off option that I told you. Here we have two plies. We have a composite stack-up that is between two machine parts. This is the actual design on the top, and then we have the FEM idealization that has the variable gaps and overlaps. You see here we have a gap, then there is an overlap, then there is a gap, and there is an overlap. So if we use this option in MSC Nastran, the OPINGP parameter equal to 1, it will automatically take care of it. You have more options, more controls to define the actual value of gap. But since we're running out of time and I have not talked about those, you can refer to the user's guide. But you can see how it improved the contact status using this parameter. The other option that we have added in Nastran is the ability to run the beams contact with segment-to-segment contact analysis. Before, with node-to-segment, it would just use a circular cross-section for the beams, and then this was creating issues. You can see, for example, here on the left-hand image, the radius of the fastener was changed. So if you have, if you want to define a fastener for two plates and that runs through a hole, like a pinhole, and designed for the bearing, you're going to have an issue if you use a node to segment. That's why we recommend using segment to segment. This has been added recently. What it does is it will take care of, it will take the cross section of your beam. So what it will do is like it will create patches for every face. So for example, the I-beam has 12 segments or 12 patches. You can see for every section of the I-beam. And then because we are using segment to segment, the shell face the shell thickness is completely included in the contact, so that's another advantage. And here you can see on the right-hand side image how we have a better chance of contact being detected, and the radius is much better, and the analysis creates much better results, and it's more accurate. So it's important to use segment to segment when you're using beam contact. It's an advantage to use it. Another option that I want to add for the new enhancements was the flexible group contact that was introduced in 2017. In the modern industries, the product structures like planes and automobiles, they all have more parts, as you guys all know, and we discussed that how using glue contact can be advantageous. But sometimes the glue contact can cause some extra stiffness because it's using the multiple constraints, and this can create some problems for customers. So it's useful still, but it's good when you're not interested for the stresses in the contacting areas. So you want to look at the areas that are further from that. That's why, in order to avoid this problem, we introduced the flexible glued contact. Because the glue contact was rigid, and it's rigid, it should be used only for the joint, for the areas that we are away from the contacting area, because the stresses may not, may be different. And you can see here we have a joint, and we have defined that with the fasteners on the left-hand side. As we expect, The load path, the load is higher on the edges, so this is actually the load path that we created here. You can draw that using Patran. And the values, you can see the fastener force, the values here. So this was modeled, the lower image was modeled using an actual CFAS element, whereas the top image was modeled with the flexible glue contact. And you can see that the results are pretty agreeable. So it's pretty good. Whereas if I use just regular glue contact, we may have had a sharp increase in the edges and not that much load in the middle. So flexible glue contact offers a more realistic way to model a fastened joint than the rigid glue contact or the permanent glue contact. So it uses the smeared stiffness properties provided by the user to simulate a flexible fastened joint. You can define two stiffness values for the glue contact joint, one in the tangential direction and one in the normal direction. And this is only supported for segment to segment. So again, this is another advantage of using segment to segment. Lastly, I want to talk about the automatic contact generation tool that we have implemented in MSC Nastran 2018. Please don't mix this with the automatic contact generation tool that we had in Patran. This one is just in MSC Nastran. So if you're using any other pre or post processor, you can use this tool. It's very good, especially for cases that you have several contacting bodies. It's much easier to set up contact. It's available in Solution 101, 103, 105, all the dynamic solutions, optimization, and the Solution 400. It will automatically create the contact bodies and contact pairs by either running the analysis completely or you can run the analysis partially to just create those. It's a very quick method to check the model. It's good for that, actually. And it creates an ACG file for you that contains all those information, and that can be read into any in your pre-post processor for further studies. So for example, here you can see we have so many, it's a complicated model, so using this, we just created 18 bodies and 7 contact pairs. You just add a parameter in your input file. So you just define BC Auto in your Nastran input file, and you have several options. The C type is for contact type. You can have touching, you can have permanent glue, you can have general glue, and you can define the distance tolerance. There are several options available to the user. So I'm not going to go over each one by one, but you can define element IDs, a set of elements that you want to put in your contact bodies. You can define it based on the property sets, or you can define it based on the rigid bodies, and etc.